This is another dynamics problem. It involves a ball that is thrown upwards from 5 meters above the ground with an initial speed of 8 meters per second. Now we find A, the maximum height measured from the ground, and B, time passed until it hits the ground. Now we go about answering this when initial conditions are here, when x equals 0, t equals 0, and our initial velocity equals 8. And its acceleration is due to gravity, which is 9.8 meters per second squared, or acceleration negative 9.8. Now a force diagram is drawn here just to help visualize this a little bit pictorially. Now the maximum height is when the ball stops moving upwards and right on the point of when it begins to fall. So the maximum height is when the velocity is 0. So we know the initial velocity equals 8 and acceleration equals minus 9.8. So we find a position x when velocity equals 0 using one of these equations, which are one of the general given equations of Newton's theory. I forgot what these equations are called now, but I'll get back to you on that. Now once we've plugged this in, we get this. So x equals 8 squared over 2 multiplied by 9.8, which equals 3.26, or approximately 3.3 meters above the point of release. Now since that's 5 meters, the maximum height is when the ball is 3.3 plus 5 equals 8.3 meters. Now to answer the second question, the ball is the ground at x equals minus 5. So we choose an equation of motion where our initial velocity is 8 and again acceleration is gravity. We want to find t when x equals minus 5 using this equation here, which plugging in the values gives this. Now we solve this with a quadratic equation, which we get this, and time must be positive, so the root of 162 must be greater than 8. So our time is here, given here, or 2.1 seconds. And that's our second problem in dynamics.